Welcome back. We are continuing in section 3.3. We're talking about vertex form of parabolas. And now that you've finished all of the Desmos graphing and you have it all graphed out in your lecture notes, let's now put this all together and see some of these transformations when they're put together. If we're looking at the whole vertex form now, it is f of x equals a times x minus h all squared plus k. And remember that a, h, and k are the important parts that are going to tell us how the parabola is being changed. All right, another thing to remember is that the vertex is h comma k. So our h and our k is what we're going to look at here. Now, on this worksheet, I want you to state the vertex and the equation of the axis of symmetry. So the axis of symmetry is a line, and it's a line that cuts that parabola in half, and one side is a mirror image of the other side. So it's an important part to know on this. All right, so what would our vertex be on this first one? So f of x equals x minus 3 all squared minus 4. Well, 3 is our h. It's the part that's telling us how far left or right it's moving, and our k value is telling us how far up or down it's moving. Now remember, since this is inside parentheses, we said insiders are liars, which is basically saying be careful when you're writing the vertex for this, because it's the opposite of the sign that's in there. Remember, we're looking to see what value of x would make this whole part go to 0. Well, negative 3 plus 3 gives us 0. So our vertex, our h value that we need is negative 3, and our k value stays just how it is at negative 4. All right, and then let's go ahead and graph this and the vertex so we can see what it looks like. So here is the graph, and if we have our vertex, we can see that it's right there at negative 3 comma negative 4. But we also need to state what the axis of symmetry is. Now the axis of symmetry is always going to go through the vertex, so the x value of that vertex is going to help you find that. Right? So remember that you're looking for a line when we're doing this axis of symmetry. You need to write it as an equation of a line. And so let's go ahead and graph this x equals 3. And you can see that is a line that if it was cut exactly down that line, that would be a mirror image on both sides of the parabola. Now let's take a look and see if we can find a few more points on this graph, because it might be kind of hard to draw it out without knowing a few more points. Now remember that the a in front of this, and on this one, our a happens to be 1. Right? It looks like there's nothing there, but there's actually an invisible 1 there that we need. So our a is 1. And so that's telling us that we can look at our graph, and if we went up 1 and right 1, we'd get to that point. And if we went up 1 and left 1, we'd also find another point on the graph. And so now that we have those 3 points, it might be a little bit easier for you to draw that over here. Now let me just clarify something on here. The reason why we could do that is because of the 1 in the front, but you can't just keep going up 1 over 1, up 1 over 1, because ultimately that would give you a straight line, right? And parabolas are not straight lines. So it only works to find the 2 points on either side of your parabola, right? To find those 3 points all together. So remember that the equation of the axis of symmetry is x equals -3 on this one. And then let's just compare this to the parent graph of y equals x squared. So if we look at this, it looks like this parabola is the same as the one that we're drawing. It's just moved. Well, where has it moved? Well, if we look at our vertex here at 0, 0, it moved 3 places to the left, and then it moved down 4 places. And that's what gives us our vertex. Left 3 and down 4. I'm going to zoom in on this one, and let's go ahead and try exercise 4C. So on this one, again, we want to know what the vertex is. And remember, our H and K is what tells us what that is. So remember, I'm going to write this underneath here. We've got our A, our H, and our K. So be careful when you're writing that X coordinate. Remember, it's the opposite. Insiders are liars. So it's going to be a positive 1, and then this K value stays just how it is. And so we have the point 1, 5. So let's look at what the graph of this is, and then we can talk about the other parts of the parabola. So here is the parabola, there is the vertex also. And so now we also need to figure out what the axis of symmetry is, right? What vertical line is going to cut it exactly in half on here. So on this one, the axis of symmetry is going to be x equals 1. Do you see how that axis of symmetry cuts right through the vertex, and our x value on there is helping us write the equation of that vertical line. Make sure you always write it down as an equation. Okay, but also we want to be able to find a couple of points on either side. If we look back at the equation again, we see that we have this -2 out in front. And so we've got to think to ourselves, what is that -2 doing as far as our A value? Well, the negative is telling us that it flipped it upside down, so that's why it's upside down. And the 2 is telling us that it's going to be more narrow than what we had. Okay, so on this one, when we're trying to figure out how we can find 2 more points to be able to graph it on the grid over here, we're going to take that -2 and kind of think of it as -2 over 1. And so I can say I'm going to go down 2 and right 1. And when I do that, I can see I have this point 2, 3. Now, since there's symmetry on these parabolas, we can also find a point that's just on the other side of that, which would be 0, 3. Again, I can go down 2, right 1, or down 2, left 1 to find those other 2 points. Now, there's a ton of other points that you could pick on the parabola, but those are just easy ones to find to help you make a rough sketch of this graph. Okay, so now I want you to go and do exercise 4B and 4D on your own. So pause your video now, try and see if you can make a rough sketch of it on your own, and then come back and let's see how you did with it. All right, so for 4B, let's see if you came up with this. All right, so on this, since we have a 0.2 out in front, that's telling us since it's positive, it's going to go up, but 0.2 is, like a fraction, right? It's not something bigger than 1. It's a number between 0 and 1. And so that decimal is telling us that we're going to have a wider parabola. All right, so our vertex on here, let's write that down, that it is -1, 2. And then our axis of symmetry has to go through that vertex, and it's going to be the line the vertical line that goes through it, -1. So x equals -1 is our axis of symmetry. And we can see that over here. Now, did you try to do 2 other points to see how wide it would be? So on this, that point 2 is telling us that we're actually going to go up by point 2 and over 1. And so that puts us at a point of 2.2. On this one, we'll go up 0.2 and then left 1. And we'll get there at that 2.2, -2, 2.2. All right, and if we compare that to the y equals x squared graph, we can see, yeah, the graph that we have is a lot wider than what our original graph looks like. Let's take a look at that next one. So on 4D, let's see if this is what you got. So did your graph look kind of skinny like this and right side up? So our vertex on this one, got to be thinking about this a little bit. So we're going to do the opposite of that, which is going to give me 4. But then there is no k value. It's like saying +0 there. So that means that we're going to have 0 as part of our vertex. So 4, 0. You can see, yep, that's where it is at there. And then we need to find our other points, and our A is telling us how we will do that. So since there's a 3 out in front, we're going to go from our vertex up 3 to the right one and up 3 to the left one, and that will give us where those points are at. Okay? And remember, our axis of symmetry goes right through our vertex at that x value. So our axis of symmetry is x equals 4. I hope you have a better understanding about parabolas in vertex form and how to graph them using these different transformations. Thank you.